Now the next thing that we should also know that if there are sequence of function calls, then how the memory is allocated inside stack. So I'll write down a piece of code, a small sample code, then I'll show you how the memory is allocated inside the stack for sequence of function calls. Here I have a sample piece of code. This is the main function. Main function is having two variables and then it is calling function fun1, and fun1 is having its a local variable x. Then it is calling function 2 and passing parameter x. This function 2 is taking parameter as I, then also it's having its own variable a. If following function calls are made, then how the memory is allocated for all these functions, let us look at it. First of all, when I want to run this program, the machine code of this program will be copied in code section. So I will write it like this. Function 2, this is the machine code of function 2, and assume that this is for function 1. And then this is main function. Now this is the machine code for this entire program. Now let us start executing. When the program starts executing, it will start from the main function. The moment it enters inside main function, it requires variable. So the memory for A and B will be allocated inside this area or this section, and that is A and B. So I'm making it as a single block. These are the two variables. Now next, main function calls function fun1. Now the control goes to function fun1. The moment control goes here, inside this, the first thing is variable is required. Variable declaration is there. So the variable is created inside the stack for this function fun1, that is x. So this piece of memory belongs to main function, and above that, this belongs to function fun1. Right now, which function is executing? Currently function fun1 is executing because we have called from here. So this topmost activation record belongs to which function? Currently executing function, that is fun1. Then fun1 will call fun2. So again the control goes to function 2. Then that is having two variables. One is its parameter, other one is its local variable. So memory is allocated for those variables I and A, and this is for function 2. Now presently function 2 is running and the topmost activation record inside this area is fun2. So currently executing function will access the topmost activation record. Now one thing you can observe that we started from main function. It has not yet finished, but it has called function 1. So main function activation record is as it is inside the stack. Then activation record for fun1 is created, means memory for fun1 is allocated. Then it is still running, but it has called fun2. So the activation record for fun2 is created and activation record of fun1 is still there in the memory. Now let us continue over execution. Fun2 is the currently executing function. Now when the function 2 has finished, terminated, then control goes back to function 1. It will come back after this point, it will come back to function 1. Inside this function 1, that is after this line, it will come to this line. Suppose there is a statement here, so it will come to this statement. What happens to the activation record of that function 2? This will be deleted. Then this, after this function 1 has finished executing this statement, it will come back to the main function after this call function 1. Let us say there is some statement, it will come to that statement. And once the function fun1 ends, its activation record is also removed from the main memory, that is from the stack. Then main function also ends. So its activation record is also deleted from main memory. So now you can see that how the activation records for sequence of function calls were created. First main function, then above that function 1 and above that function 2. Right now function 2 is running. These are already there in the memory. When function 2 ends, it will delete and come back here. When it ends, delete and come back here. When it ends, delete and the program ends. So the way activation records are created like this and then deleted like this. So this mechanism is stack, right? top and top and top, then delete, delete. So this mechanism is stack. So that's why this section of memory behaves like a stack during the function call. So that's why it is named as stack. So that's all. This is how the main memory is used, or stack memory is used for function calls. Now one important thing to observe. How much memory is required by a function depends on the number of variables and their sizes. And this is decided by compiler only. So this memory is automatically created and automatically destroyed. Programmer doesn't have to do anything for its allocation and destruction. Just programmer has to declare the variable. So the conclusion is, whatever the variables you declare in the program or whatever the parameters your functions are taking, for all of them, memory is allocated inside the stack and it is automatically created and automatically destroyed when the function ends. Now next we'll talk about heap and see how memory is dynamically allocated from heap. Now let us learn how heap memory is utilized by a program. So I have taken a main function. This is a main function, so I am showing the code here, and this memory already we have seen. Now we have to see heap. First let us understand the term heap. Heap means what? Just piling up. If the things are kept one above another or just randomly, we use the term heap. So heap is used in two cases. One, if the things are properly organized like a tower-like thing, then also it's a heap. And if it is not organized and also it's looking like a tower, then also we call it as heap. So the important point is, heap word or term heap can be used for organized thing as well as unorganized thing. So here heap is the term used for unorganized memory. It's not organized. Stack memory is organized, right? We already saw how the activation records are created and deleted, but that is not organized. This is the first point. And the second point about heap is that heap memory should be treated like a resource. So I'll tell you something about the resource in applications. See, suppose a printer is a resource for your program. If your program want to use a printer, then it can request for a printer, use the printer. Once it has finished using it, it should release the printer so that the other applications can use it. Same way, heap memory should be used like a resource. When required, you take the memory. When you don't require, you release the memory. This is the practice that we must do while dealing with heap memory. So I told you 2 points. What is heap? Second thing, it should be treated as a resource. Now the third important point, program cannot directly access heap memory. It can directly access anything inside code section, anything inside stack, but it will not access heap memory. That is like a policy of a program, that it will not access heap memory. It can if it want, but it will not access heap memory. So programs cannot access heap memory directly. Then how do they access heap memory? Using pointer. So let me show you how we can get some memory inside the heap with the help of a pointer. Let us check it. First of all, for taking some memory, I have to take a pointer. Now the first question, how many bytes pointer takes? In my discussion, for making it simple, I say that pointer takes 2 bytes. Actually, the amount of memory taken by pointer depends on size of integer usually. If integer is 2 bytes, pointer is 2 bytes. Integer is 4 bytes, so pointer is 4 bytes. So let us assume that it is taking 2 bytes. So let us just assume that pointer is taking 2 bytes. So this needs 2 bytes. Now, next point. Where the memory for the pointer will be allocated? See, just now in the static memory allocation, I told you that what all the variables you declare in your functions, they will occupy memory inside the stack in their activation record. So yes, for this pointer, memory is allocated here. So this is a pointer. So it takes 2 bytes. So 2 bytes of memory, and this is the activation record for main function. Now I want to allocate memory in heap. So how much memory I want to allocate? I want to create an array of integer of size 5. So this new statement will allocate memory in heap of size 5. So array of size 5. and this pointer will point on this one. Suppose the address of this location, the beginning address is 500, so 500 is stored here. This is the method of allocating memory in heap. So wherever you see new means memory is allocated in heap. Simple variable declaration, memory is allocated inside stack. In C++, it is new. But if I write same thing in C language, then I have to use malloc function or malloc function, and I want 5 integers. So 5 integer, assume integer takes 2 bytes. So this is 2, and I have to typecast it as integer type. So this happens in C++ and this happens in C language. So this is the code for C++, this is the code for C language. Most of the time I'll be using this one, right? This is little lengthy, so I will be writing this one. So that's all. New is used for allocating memory in the heap. Now program cannot directly access that, it has to access pointer. Pointer will give the address of that memory, then the program can reach that location and access these integers. Now, one thing I told you that heap memory should be treated like a resource. After some time in your program, if you don't need that array and you want to make p as null, means you don't want this pointer p to point there, you don't need that memory anymore and you don't want the pointer to point there, so you can make the pointer null. So nothing will be pointing on to this one. Then what about that memory? Is it lost? Is it gone? No, it will not be deallocated. So it's a good practice that when you don't need the memory, you should deallocate it. As you have requested for the allocation, same way you should request deallocation of the memory. So say delete p. You must say delete. As it's an array, so you have to say this one. So when you say delete, this memory will be deleted. And then you can make the pointer as null, so this will become 0. This is not pointing on this location. So that's how heap memory should be explicitly requested and explicitly released or disposed. Otherwise, if you are not releasing it, then the memory will be still belonging to your program and that memory cannot be used again. So it causes loss of memory, and the loss of memory is called as memory leak. And if you continue the same thing in the program for many times, then at one stage the heap memory may be full. There is no free space in heap memory. So whenever you allocate the memory, heap memory, and if you don't need it, release the memory. So let us conclude. We have seen static memory allocation that was done inside the stack for all the variables. Then we have seen heap memory allocation. It is done with the help of pointers, and when not in use, it must be released. So finally we conclude here. We have seen how the static memory allocation is done from the stack and how dynamic memory allocation is done from the heap. So this is the difference between stack and heap. So then in next video, I'll give you introduction to various data structures.